Hello everyone, welcome to Logicpedia where logic is power. I am Saransh Dave and today we are going to discuss our first ever Logicpedia Weekend Puzzle. So let's get started right away. Our first weekend puzzle is a foldable conductor with 11 joints and 12 segments is used for connecting a battery to a heater. The joints can only be at a position such that the corresponding segments are allowed to be only at 90-degree angles to each other in left or right directions. Assuming that the first joint is towards the right, that is, the second segment is in 90-degree clockwise direction with respect to the first segment, and any overlapping will cause a short circuit, find the number of safe orientations. The figure below shows a possible safe orientation. So you can go through this problem once again to be thorough with the understanding. Uh, I've taken this problem from Technotron Logic Week 4. This is actually the question number 2 from Logic Week 4 of Technotron. You can go give this question a look by yourself on Instagram. Just search for Technotron Logic Week 4 and you should be able to find it easily. So, okay, let's go through this question once again. So, we are given a foldable conductor with 11 joints and 12 segments. So, on this in this sample figure, we can show that we are given a conductor with 12 segments and 11 joints. So, joints are basically the intersection points of two segments. So, we can see that there are 1 2 3 4 5 6 7 8 9 10 and 11 joints, and there are 12 segments. So yeah, this is consistent with our given information. So foldable conductor with 11 joints and 12 segments is used for connecting a battery to a heater. Okay, the joints can only be at a position such that the corresponding segments are allowed to be only at 90-degree angles to each other in left or right directions. So this basically means that all the segments has to be perpendicular to each other, and they can either be in left or right directions with respect to their previous segment. Okay, so assuming that the first joint is towards the right, this is the most important thing. Assuming that the first joint is towards the right, that is, the second segment is in 90-degree clockwise direction with respect to the first segment, and any overlapping will cause a short circuit. Find the number of safe orientations. So in this statement, the most important thing to be noted is first joint is towards the right. So this statement basically means that from wherever we start considering the orientation of segments, the second segment always has to be in a 90-degree clockwise direction with respect to the first segment. So here, if we consider that we are here, if we consider that this is our first segment, so we can see that the second segment which is there is at a 90-degree clockwise direction with respect to this segment, or we can say that it is in right direction with respect to this segment. So yeah, that too is consistent with the given information, and we need to find the number of safe orientations given these constraints. Okay, so let's solve this problem. Let's solve this problem. So let's be thorough with the representations we are going to use throughout the solution. So I'm going to represent a segment like this, two black dots connected by a black straight line, and just for clarity of where the segments are starting from, I'll be representing the starting segment with a red color. So these are a few invalid cases. So as we were told that we don't need a short circuit, right? So a short circuit will occur only when there is an overlapping of segments. So whenever there is an overlapping of segments, there definitely is a formation of loops. So we can say that basically we don't need loops in our orientations, right? So some possible loops could be as these shown loops. So the first loop is a squared loop where we have four sides, four segments, and a loop is formed. And second possible loop could be this plus oriented loop where we have 12 segments, and so on. We can also have other loops, and this third example loop is a loop formed using 18 segments, I guess. Yeah, it is formed using 18. It is a loop formed by using 18 segments. Okay, so let's carry on. So to try to tackle this problem, let's try it out for small cases, and let's see if we can find a pattern in it. So that way we can simplify, our understanding and tackle the problem easily. Okay, so here n is basically the number of segments we are considering. So if we want to find the number of safe orientations given only one segment, it's quite obvious to see that number of safe orientations will be only one. That will be the segment itself. Uh, so yeah, for n equals to 1, we get one safe orientation. So f of 1 equals to 1. And if we consider the number of segments to be 2, because we are given the constraint that the second segment always has to be in the right direction with respect to the first segment, again we end up with only one possibility. So also f of 2 is equals to 1. For n equals to 3, however, we can see that the third segment, which is there, the first two segments are similar to as they were in n equals to 2 case. But the third segment, we can see that in this first case, the third segment is in 90-degree clockwise direction with respect to the second segment, and in this second case, it is in 90-degree anti-clockwise direction with respect to the second segment. So here we get two distinct possibilities. So for n equals to for n equals to 3, we end up with two different safe orientations. So f of 3 equals to 2. Similarly, we can also work out for n equals to 4, 5, and 6. You can go through these orientations by yourselves, and basically what you will observe is for n equals to 4, we end up with 3 possible safe orientations. For n equals to 5, we end up with 5 possible safe orientations, and for n equals to 6, we end up with 8 possible safe orientations. So now let's try to understand this pattern. So we see that for f of 1 we are getting 1, for f of 2 we are getting 1, for f of 3 we are getting 2, for f of 4 we are getting 3, for f of 5 we are getting 5, for f of 6 we are getting 8. Should we get 13 for f of 7? So is this pattern looking familiar to a pattern we already know? So many of you might have already guessed. Many of you might have already guessed that this looks quite similar to Fibonacci pattern, but we still need to verify if it indeed follows this Fibonacci pattern or not. Okay, so let's for a moment assume that it indeed does follow the Fibonacci pattern. So if it does follow the Fibonacci pattern, then our answer should be 144, because for n equals to 1 we got our answer as 1, for n equals to 2 we got it as 1, for n equals to 3 we got 2, for 4 we got 3, for 5 we got 5, for 6 we got 8, and so similarly for 12 segments we should end up with 144 safe orientations. So is 144 indeed the correct answer? So let's check it. So now we have understood that this is sort of following a Fibonacci pattern, but if it indeed is following a Fibonacci pattern, we need to understand why is it following this pattern. So this why is what we are going to look into in our next slide. Yeah. So this, I can assure you, is the most important slide of all. As we are going to understand why we are getting a Fibonacci sequence. So what I've done here is I've considered f of n, that is we need to find the number of safe orientations for given n segments. So I've divided this into two parts. So the first set of orientations is a set of orientations where the third segment is oriented in left direction with respect to the second segment, and the second set of orientations are the cases where the third segment is in right direction with respect to the second segment. Yeah. So in this first set of orientations, we have assumed that the third segment is in left direction with respect to the second segment, and we fix this second and third segment. We ignore the first segment for calculations because it anyway is fixed, so it won't matter. And fixing segment number 2 and segment number 3 is sort of giving us a similar formulation to f of n minus 1, because here we need to find the number of orientations in n minus 1 segments where the first two segments are fixed. So now one might get a doubt that in the question we were mentioned that the second segment has to be in clockwise direction, in 90-degree clockwise direction with respect to the first segment, but here it is actually in 90-degree anti-clockwise direction with respect to the first segment. So yeah, true, this is the other way around. Here the second segment is in left direction with respect to the first one, but that is not actually changing the number of possible orientations for it is basically not changing the value of f of n minus 1, because anyway if we see the number of orientations considering the second segment to be towards the left of first segment, it is mapping to some mirror image of an equivalent orientation in the cases where the second segment is towards the right of the first segment. So the point is, if you think about it, you will find that uh, the number of orientations given the number of segments remains the same whether we fix the second segment to be towards the left of the first segment or we fix it towards the right of the first segment. So whatever convention we follow, we are going to end up with the same number of orientations whether we consider the second segment to be towards the right or towards the left. So here uh, we have fixed segment number 2 and segment number 3, and we have formulated this to an equivalent number of orientations given n minus 1 segments. So for this set of possibilities we get a number of orientations as f of n minus 1. Now let's take a look at the other set of possibilities. So this other set of orientations consider the third segment to be towards the right of the first segment. Here we can see that after placing the third segment towards the right of second segment, we cannot actually place the fourth segment towards the right of third segment, because if we do so we'll actually be completing the square loop, which is not our requirement. We want to avoid forming square loops or in general any loop. So to make sure that we don't consider this loop, what we do is instead of fixing segment 2 and segment 3, because we want to restrain our possibilities to form a loop, what we'll do is we'll instead fix segment number 3 and segment number 4. So this is the main point behind fixing segment number 3 and segment number 4 is to make sure that a square loop never occurs. If we didn't put this constraint, then the fourth segment could also have formed a loop, and we might not have got the correct number of safe orientations. So in this second set of possibilities, what we do is we fix our first and second segments. We uh, we then we fix the third and fourth segment, and we start calculating the orientations from the third segment. So in this formulation we can see, as here in calculation we have only n minus 1 edges, so we end up with f of n minus 1, and in this set of orientations we consider n minus 2 segments in our calculation, so we end up with f of n minus 2, and we finally have f of n equals to f of n minus 1 plus f of n minus 2. So here we have got the Fibonacci formulation, but the Fibonacci formulation is not just this recursive formulation that f of n is f of n minus 1 plus f of n minus 2. We also need to see the base cases. So previously we have already seen that f of 1 was equals to 1 and f of 2 was equals to 1. So we already have the base cases, and so we can verify that this indeed is a Fibonacci pattern. So is this indeed a Fibonacci pattern? So yeah, it does look like so. But have we taken everything into consideration? The answer is no. We've avoided only the square loops. We might still get the plus oriented loops which we have seen previously, right? So I'm talking about this set of possibilities. So sorry about that. Yeah. So what I'm saying is we can still get this possibility. Yeah. So if we were asked to find the number of safe possibilities in 11 segments, then maybe we could have said that yeah, it will follow a Fibonacci pattern, and we'll get the 11th Fibonacci number as our answer. But because we are given to find the number of safe orientations given 12 segments, we also need to eliminate the possibilities of the formulation of plus oriented segments. So we need to subtract the plus orientations, right? So these are the missed out cases. These are the plus orientations I was talking about. So these are three missed out cases. So the first missed out case is when our starting segment is on the upper side of this plus, and the second case is when our starting point is somewhere here, and the third missed out case is when our starting point is here. So basically you can also ask that why not keep the starting point somewhere like why can't we keep our starting point here? So basically we cannot keep our starting point here because we need to make sure that the second segment is towards the right with respect to the first segment. So basically we need to make sure that the second segment is at an angle of 90-degree in clockwise direction with respect to the first segment, which is not being followed if we take any other horizontal segment except these three as shown. Yeah, so these were the missed out cases. So finally we again ask us this question: so is 144 the correct answer? So no, it is not the correct answer. We also need to subtract the missed out cases from
144. So there were three missed out cases. So we end up with our answer as 144 minus 3 equals to 141. So yeah, the answer to our question is 141, and yeah, that's it. So yeah, thanks for watching this video and have a nice day. Goodbye.